Thanks a lot for taking time and coming to attend this session. I know being the last day of VMware. So the topic for discussion today is advanced troubleshooting of ESXi. I'm sure all of you would have gone through the disclaimer statements a couple of times by now, so I'm just going to skip through it. Being in Vegas, I'm sure all of you would be happy to see the screen hitting jackpot 777, right? Being in technical world, I'm sure that it would bring smiles in all your face. chmod 777, wherein you give full permission to a file, but here we're giving full permission to a user. So before we begin, a quick check. In ESXi server, how many configuration files do you have? I'm sure all of us worked with ESXi for so long time, I don't think we never took time to think how many configuration files do we have. Anyone? Lots. That's a good answer. How many commands do we have? Even more lots? Okay, that's also a pretty good answer. How many log files do we have in ESXi? Okay, so the number of configuration files we have is close to 50 plus. The number of commands in an ESXi is 300 plus. And the number of unique log files, if you just take the var log location, there are 40 plus log files. Wondering why? Now, the objective of a session is to help improvise your troubleshooting techniques and tools that can help some of the common issues in your ESXi. I'm sure now you would have correlated the significance of the number 777 we saw till now. So we would like to equip you with 7 commands, 7 log files, and 7 configuration files that would come in handy for troubleshooting any issue. All of us know lots of commands, configuration files, and log files. But which log files to check for which issue? Which command would help me to isolate and troubleshoot any issue? Which configuration file forms the backbone of any troubleshooting? That's what we will equip you by end of this session. I'm sure you would ask the question, why number 7? Every VMware session is time bound, and given the time, we will try to cover as much as possible. For all other questions, we are always a call away. So this is how the agenda for the day looks like. We will look at the 777. And before we begin, we would like to go through the architecture of ESXi quickly. So all of you know that the underlying is the server hardware. The core component of ESXi is the VM kernel, which is one of the core component in, say for example, VM kernel does is your resource scheduler. This is the component that is going to allocate all the resources required for all the virtual machines in your ESXi. The next core component is hostd, which you'll be seeing on here on the blue color box. I'm sure you'd have heard of it multiple times by now. That manages all the process and key components in your ESXi. Next is VPXA, which any instructions given by your vCenter, what we call as VPXD, is given to VPXA and then talks to your hostd. So if you launch a vSphere client, or if you launch a client to your vCenter, the instruction goes from VPXD to VPXA to hostd. If you launch a client direct to the ESXi, that talks directly to hostd and executes the instruction. Another key core component is your VMM, what we call as a virtual machine monitor, which is responsible for your virtual machine files and all that. Now let's discuss a real world scenario, which I'm sure all of you would have seen in your environment. The first one, I would like to know if my host got rebooted. For some odd reason, if my host got rebooted, how will I check if it got rebooted or not? Okay, the host got rebooted. Now, when I power it back on, it takes a long time to boot. Okay, I resolve that issue somehow. The host comes up. What's next? It is showing as not responding or disconnected in your vCenter server. I resolve that issue. Now I'm not able to power on my VM. Maybe one of the underlying causes could be storage. Why is there a problem with my storage? It could be an ESXi or NFS, which is caused by your networking issue. I overcome all these hurdles. Now comes the million-dollar question: did my HA kick in or not when the host got isolated? So these are 7 different scenarios which you would have seen in your environment. I'm sure at least one of these scenarios you'd have seen, right? So these are the 7 different scenarios we are going to discuss about in detail. And if you identify any of these issues in your environment, which is the log file that you should check? That's what we are going to begin discuss with. The first scenario is your host rebooted. I know one of my hosts got abruptly rebooted. Which is the log file that you check? vmksummary.log. So in an ideal case, this is how the vmksummary dot should look like. You know, your VM kernel should be aware that the host was rebooted and the host got booted up again. But none of us work in an ideal world scenario, right? This is how, if a host got abruptly rebooted, this is how the log file will look like. The VM kernel would have monitored only that the host came up. Now, why the host got abruptly rebooted? The major cause could be a hardware problem. Now, what will happen is, most of the servers that are coming these days comes with a feature called ASR, Automated System Recovery, and this is in your BIOS. If it detects that there is some hardware that's causing a trouble, what it will do is, it will not wait for it. It triggers the IPMI and the server goes for a reboot. So how will I be able to identify what is the problem, what is the hardware component that's causing the trouble? What you do, you disable your ASR and you let your ESXi server crash. When it crashes with a purple screen of death, or what we call as a PSOT, we will be able to isolate which is the hardware component that's causing the trouble. Now, what could be the other causes wherein a host could abruptly reboot? Simple thing is if someone presses the reset button. When that indicates that the problem is between the keyboard and the chair.
All right, let's start with the next we'll continue the same scenario that we started with. So let's assume the host has come up and we are seeing the host boot up is very slow. How many of you have actually seen this problem in your environment? Boot up slow? I see a lot of hands up there. All right, so ideal approach to troubleshoot boot slowness would be looking into the boot.gz logs. So the location for this log file is var log location. Now, okay, I have the boot.gz. What do I do next? So to start with, when the host boots up, you have VM kernel that is loading successfully. So in the boot.gz logs, if you look at, it will give you a timestamp and it will tell you that the VM kernel has loaded successfully. From which, by design, the kernel will load up and then you'll have the jump start, which is a module which will start loading all your other modules like your HBA driver, your network card driver, and all these modules. Now, the way how we approach slow boot issues is start off from the timestamp where the kernel has loaded successfully and then walk yourself downwards, right? Each and every time you look at the timestamp, you will see one timestamp where the kernel is spending more time to populate. It may be an RDM where it is looking at the RDM and it's spending more time. It may be any other module as well, right? So the other option to initiate a live troubleshooting is to look at, Alt and F12. So under the direct console user interface, you have Alt and F12. If you hit the key Alt and F12, you will see the kernel live logging messages. In a worst case scenario, let's assume that the host does not have persistent logging. So what do we do next? So at the boot up phase itself, so this is option number 3, folks. So at the boot up phase itself, you can actually hit the keystroke is Shift and O as in Oscar, okay? So if you hit this, you will get a boot prompt where it is not going to boot but you can enter additional key parameters where I can enable serial logging or persistent scratch partition, and then I can move on from there. So this will give me ability to capture the kernel dump or the kernel logs to investigate what went wrong. Now let's move on. So the most common issue that we come across, there are many RDMs presented on my host, and the RDMs are not flagged perennially reserved. How many of you have actually used this? Awesome. So the command that you see is ESXi storage core set config against the NAA device itself, where we mark the device as perennially reserved. Now, I know most of us do this. We initiate a script, we flag all the LUNs. So we still find out some of the LUNs have been missed out. So how do you even investigate that piece? Now, what we can do is we can look at the ESX.conf. So ESX.conf file saves all your information of your host itself. It also saves the LUNs that are marked for perennially reserved. You have a key flag that is highlighted right there on the screenshot where it says perennially reserved equals to true. So the ones that are not are pretty much understood that they are not flagged with the perennially reserved flag itself. So let's move on with the next issue. Let's say the host came up and we have the host is now not responding in your vCenter. So how do we even troubleshoot that? Before I go into the details there, I would want to touch base on the architecture which Raghav just showed up, right? So the host D component, when we are troubleshooting, based on the architecture, the vSphere client or your host client that you have directly connects to the host D as such, right? And when you're using a web client connect, the web client connects to your VPXD, and the VPXD connects to the VPXA on the host, and then the VPXA actually talks to the host D. So whenever you connect through your web client, you have a roundabout connect to the host D itself. So when the host is disconnected, there are two ways to approach, right? So you have a host client connect directly to the host to validate if the host D as a process is working or not. That's point number one. Now let's say the connection succeeded. I'm able to connect the host without any problems. That means that the VPXA on the host is unable to talk to the VPXD on the vCenter. The host D is working fine now. Are we on the same page? Fair enough. So that goes to a different troubleshooting approach altogether, where I will look into my ports, my physical network, and then it goes to the other side. So let's restrict on the host D itself. Let's assume I initiated a host client connect to the host and the host did not even connect. It says failed. So what do we do next? So there is a file called hostprobe.log in your var log location. So the duty of this probe daemon is to query the host D process and to validate if the host D is up and running or not. Now, you can call it a watchdog, but it's not a watchdog. We also have another watchdog file, okay? So the key word to look at on the hostprobe.log is to see if generically it's plain text English telling that the host D is non-responsive. Now, yes, I found that the host D is non-responsive, so what next? So I'm sure most of you would go ahead, restart the host D services and then check out. I'm sure there's a lot of KB articles that has these commands. But for you folks, as a takeaway, if you want to continue and pursue an RCA or a root cause to understand where or what happened to the host D, restarting the process will kill the current memory state of that host D process. So it's always recommended that you contact the support team and they will help you capture the live core dump of that process itself so that we can investigate what went wrong there. Right? It can be a storage issue, it can be anything, right? Now, let's assume that you initiated a restart of the host D process. And, how do we even investigate or validate if it is successful? Did it even come up fine or not? So, a simple and an effective command is to look at vim-cmd vmsvc get all VMs. So I'll just go one slide back. So if you look at the second point that tells, every time the host D starts successfully, the last activity that it does is to query the vminventory.xml file. So what is this file? This file hosts all your VM registered in that particular host. It is going to populate that, and then it is going to start up successfully, right? So this command is going to read through the host D. It's going to query the host D. The host D is going to query the inventory.xml file and then populate the output for you. Now, if this command fails, that is one option to understand that the host D is not started. Now, the output should show you all the VMs that are registered on that particular host. Now, the second option that you have from the hostd.log, once you have restarted the services, I will query the hostd.log and then look out for the keyword called begin services. That is the last message that the hostd will leave. And the hostd.log will show you begin services that claims or that proves that the hostd is up and running now. And then your connect should go through fine. So let's assume that the host connected. The next thing I'm supposed to do is to power on my VM. I'm attempting a power on and the power on fails, right? An ideal approach for power on issues on a VM should be looking at the vmware.log file. There are multiple other files as well, but an ideal approach should be looking at the vmware.log file. Now, let's take a scenario where we are talking about the VM is running on snapshots. I have two levels of snapshots, snapshot 2, which is mapped on snapshot 1, and then the snapshot 1 has been mapped to the base disk. Now the attempt on a power on fails. What should I do next? Now, there is a command that we have, which we're going to talk about in the next coming slide, where we can check the chain consistency between the snapshots themselves. That is one way of looking at it. But that command will not help you to fix the chain itself if it is broken. Now the easiest way or a simpler approach would be looking at the the vmware.log file. So just to give you a understanding of what happens at the back end when you power on a VM. The VMX, which is a configuration file of a VM, is being read. Every component that you have, the memory, the CPU, your disk, virtual disk, your network card, maybe VMXnet 3 or whatever you have, everything is read. It completes that read. Let's say if the VM is running on snapshots, I will have to query all the snapshots all the way to the base and then successfully power on. Now if it stalls is where you see such messages. This is a classic message where it says, I am looking at or I'm querying at the 0001.vmdk. So it is actually querying at the delta file or the vmdk file of that particular disk, and then you're seeing a content ID mismatch. It is also giving you a parent content ID information. So it says the first number, which is A56AB7FD. That is the number that exists on your file. But the actual file is the answer right there itself. So you'll have to replace. So all you do next is go back to that same file, which is 001.vmdk, do a VI. Before you do a VI, make sure you have a backup, okay? We don't want to run into more issues. And then change that value as is, and then you can execute the chain consistency check command to make sure we are intact. And then your power on should successfully go through. As I said, this is one of the scenarios, right, where we can use vmware.log. There are many other things that we can use it for as well.
So till now what we saw was my host got abruptly rebooted. I powered it on, it had slow boot issues. I overcame that. I was able to power on my VM. But I tried to power on, it didn't go through. One of the reasons here we discussed was snapshot, but the underlying issue could also be your storage. So for any storage related issues, the log file that first ideally we will look at is your vmkernel.log. Whenever there's a storage issue, the first thing that we see is my VMFS volume is missing, right? But it could in reality, it could be the HBA itself is not detected, or there's a problem with the LAN, or the problem could be with the partition table, or the problem could be with the VMFS file system itself. Any of these issues, the vmkernel.log will give you the clue as where you should start your storage troubleshooting. Most of the storage-related issues can be troubleshooted by the SCSI sense codes. So here the key file that you need to check for SCSI sense codes would be to begin with SCSI device IO, which is highlighted over there. The next thing would be is the key messages for your failed. You can see the command. The command indicates whether it's a read command, write command, and all that. The next is the failed, HDP. H indicates it's the host, D is for device, P is for the plugin. And the next is data, sense data you see, that indicates whether this particular command was successful or failure. Now I understand that these are all hex codes. How do I make some intelligence out of it as whether is it a read command, write command, did it fail at the host level, device level? To read all this, the T10 org, I'm sure all of you would have known these links. The T10 is the technical committee that defines the SCSI standards. But that's for the command. Now, if I want to know whether that HDP and did that command complete successfully or not, you can look at the verten.net. Even if you Google, that's the first blog link which you will get. You just put in the values over there. That will tell you whether was that, for that particular device, was it a check condition or is it a message that you can safely ignore? Like say, for example, if you're using Log Insight or any other log parser tool, whenever any messages like these comes up, it will automatically pick up and it will show you. So you don't have to be really worried. Look at the SCSI sense code and then decide, is it something that you need to action or is it something that you can safely ignore? Now, I know that, okay, for storage issues, vmkernel.log is the one that I should check. What if, now if it's a fiber channel, what if it's an iSCSI or NFS? There could be underlying network issues as well that could cause my problem with the storage. So this is a classic scenario of an iSCSI or any networking issues. Now, any networking issues, the first log file that we would check would be the vobd.log. vobd is nothing but the toned down version of VM kernel. VM kernel not just contains with storage, but it contains lots of other issues as well. So any storage or network related issues, vobd is the first log file to look at. Say in this scenario, what we have looked at is looking at the bottom screenshot. If you look at it, it says storage disconnect message. It clearly indicates that my iSCSI had a disconnect over there. If you see here, it says there's a network connection failure. So the problem could be with your link is down, or there could be a problem in the network switch, or the problem could be with the network port in your storage array itself. So how do I isolate where the problem lies? So I dig deep into the log files. That's the first screenshot that you see up there. The keyword to search is uplink. When there's a network connection failure I find, the next keyword I search is uplink. And what I find in this particular issue is, yes, my uplink went down, which triggered my storage to go down. Whenever there is a network issue, not necessary that it's only that the link is up or down. Most of the times we find that it could be a network congestion in your switch as well, or the problem could be with the storage array port. So whenever there is a network troubleshooting, or if you're going to do a packet capture as well, please ensure that the packet capture is done from source to the destination. Only that will give you a holistic picture of where exactly the packet drops or where exactly the congestion happens.
All right. So coming back to the million-dollar question again, what happened to my host? Why did, what happened? Did it reboot? If it is rebooted, has my VMs powered on? Did it trigger an HA and then did it power it on a different host or not? So predominantly we will, again, the ideal approach is to look at fdm.log. Now, fdm.log has tons of other logging as well. So you have cluster configuration, I can go on. You have, in case if you have FT, fault tolerance in your system, you will have more tons of logging that is going into fdm.log. How to just keep it simple and then initiate a logical troubleshooting approach to understand what just happened. So the key points have been listed out. So you have, what is the host ID? The host that got isolated or rebooted? Was it a host, was it a slave or a master? And then what is the IP address of that particular host itself, right? So I'm sure not many of you know this. There is a command, or there's a script I would call it. It's called as prettyprint.sh. So you can see it right there. So it is OPT, the location is OPT, VMware, FDM, and then you have prettyprint.sh. So ideally this script is used for log bundle collection purposes. So if you're initiating a log bundle, this executes and it will pull out some information about the host and the cluster configuration on the HA itself, right? Now, all I'm doing is looking at the host list inside that particular script. It is actually telling me that the host ID itself and the IP address of the host, and it also gives me details about the version details and everything. So all I need is the host ID and the IP address of the host. Once I have that, I will go to the fdm.log and then look up for the host ID that I'm concerned with. So for this example, it shows host ID equals to 10 and the state shows it is slave. And the master host ID node shows 29. That means I can look up for the master, which is host ID 29, and then look up for the timestamp when this rebooted and then see what is the master doing during that time. So did it reboot all the VMs? What action did it take? So I can search it based on the host ID. So similarly, I can also look at host ID 10 itself, where it will tell me what happened to that host. Did it isolate? Did it get network partitioned, and so on. So this is a startup phase where you can look into and then query, understand what has happened with the HA failover. Did it even go through fine? I mean, based on the host ID information, you can start troubleshooting of what happened with my cluster. So I think we have come up at the end of 7 different log files and then different scenarios based on them as well. But that does not limit the usage of these files. These files can be used for many other purposes also, right? Now, before I go further more, right? I'm sure this is the Thursday of the last day of Las Vegas. Can we hear a yes if you all like the session now? Awesome. Okay, let's move on. So we'll talk about 7 commands, effective commands. Some of them you might have seen already, right? We're going to talk about some uniqueness on them which you may not have seen till date. And then some commands I'm sure you may not even have been seen till date, where we're going to expose them. We use that in the support. We're going to share it with you all so that you can also have that same kind of troubleshooting approach heading forward. So the first one, which we already know, it's ESXi. So ESXi has storage, networking, we have system, we have software, and we have vSAN and VM as well. Now, one key thing or one important thing that we all need to keep in mind is ESXi, when you execute this command against an SSH on the host, let's assume that the command hit is taking a longer time. It's just hung right there. And it's not executing the command successfully at all. That also points that the host D has a problem. Because ESXi command traverses right through the host D. The host D is the one that's executing this using its system calls. Now the way of working around this is to use local CLI instead of ESXi. That's one key thing, right? So we'll see what is the use case of ESXi, right? So you can actually list out. So this command, ESXi network IP neighbor list, can show you the ARP information of the neighbor host. So it is actually going to give you the IP address and the kernel port details of my neighboring host itself. And this one command, I would request all of you to keep this in your mind so that it'll help us in the further slides. ESXi VM process list. It is actually going to give me the registered VMs in my host and their processes and their runtime path. So I have the location itself gives me where is it even located at. Now, a couple of additional information is it's going to tell you the world ID of that VM. That's point number 1. The second point is it's going to also display the cartel ID, VMX cartel ID of that VM. Right? We will talk about where we can use this in troubleshooting. So VSISH, which is VM kernel system info shell command. Now, we have, many of them may not have even seen this, but you can, I would strongly suggest you stick on to the get option, and then make sure no changes have been done using anything else. So, restrict yourself by using only the get option, because the changes are going to get impacted directly on the kernel, okay? Now, the first option which I would want to bring up is to understand your hardware details of the host itself. So I can look up on get and then BIOS and then the hardware info itself, which will tell me what is the BIOS information or the version of the BIOS on the host, the hardware details as well. Now, little more diving into some effective troubleshooting steps, right? So you can actually look at vshish get, you can go to the pnix, physical NICs of the host, and then you can give the uplink name which you want to look up for, and the stats information. So it's going to give you the statistics of that particular uplink. You can also execute that on the vSwitch layer as well. So it's going to, if you say vSwitch 0, it's going to give you the vSwitch 0's statistics. So what are the statistics it's going to talk about? It's going to talk about drops, if there are CRC errors, receive missed errors or transmit missed errors, and so on. So pretty neat. The similar ones you have it for storage as well, which can tell you the drop frames, abort messages, if there are HBA errors and things like that, and specific to devices as well. Let's say your LUN's just getting hammered with latency, and then how do I even investigate it? So that's the first place that I would look at. Now, this is going to give me a real-time information of what the host is seeing at that point in time, right? So the ideal approach of troubleshooting would be I capture my first set of snippets, let's say drops I'm looking for. I capture that right now, and then I leave it for another hour or maybe half an hour or so, and then capture the next set of them. And then see if there is an increment in that number. That gives me an analysis that there is a drop going on, or there are aborts going on in my maybe the storage or my network as well. So we will talk about one effective troubleshooting tip from VSISH itself to understand if your VM is properly allocated with the vCPU or not. So let's say this is a given scenario, okay? So the VM is allocated with 2 vCPUs, and the VM is always hovering at 100% and above. So what do I do next? How do I even investigate if 2 vCPUs is enough or not? So most of us will start troubleshooting from within the guest OS, see what is the process going on and things like that. To make it more simpler, I would rather push this approach, right? Now, remember we spoke about the cartel ID with ESXi VM process list. So you can use that approach to get the cartel ID. So the number that you're seeing, 39976, is the cartel ID information. So I'm looking at PS, and then I'm grepping for the process for that VMX and the VM itself, and I'm getting the cartel ID of that VM, right? Once I get the cartel ID, I will execute the command called vshish, VSISH, and then I will query for get skeds and then vCPU, and then I will enter the cartel ID information, which is 39976, and the group ID. So I'm going to retrieve the group ID from the cartel ID's information. So what do I do with this group ID next? You can also get the group ID, before I go further, you can also get the group ID by running ESX stop and then V for virtual machine. I get the group ID and the VM itself. This is another way that you can also pull it from. So once I have this, I will execute the command get and then skeds group, and then I'll give the group ID information. I will execute stats and then say CPU stats dir and then CPU stats. So it's going to display the statistics of the CPU allocated for that VM. You get a number of things here. So I'm not going to go into more details about all the parameters. So network latency, storage latency are one of them, and then the one that I would really want to talk about based on our scenario here is demand and entitlement ratio. So let's assume that the 2 vCPU VM that you have is always at 100% usage. So if that is the case, if you see this value of demand and entitlement ratio above 100, 100 is the value of equilibrium. If it is 100, that means that the VM is actually getting what it's supposed to get, and that is the right value that's supposed to be. If it is way beyond 100, let's say 150 and so on, that means the VM is getting hammered and you're supposed to allocate more vCPUs for the VM itself. Now, let's say the value went way below. It's around at 50 or 25. So you might, there can be a suspect that this can be over provisioned. So I've allocated more resources to that VM than what it is required with. So you might want to go to ESX stop, check the percentage ready value of it, and then see if it is over provisioning or not, right? So as a takeaway, I would again rephrase and summarize. If the value is 100, it is equilibrium. If it is beyond 100, that means that the VM needs more vCPUs. Fair enough?
So the third command that we're going to discuss is the vim-cmd. I'm sure most of you would have used it at least once. It could be to register a VM. It could be to power on a VM. You can do all these things from the command line. One of the key information for vim-cmd that most of them does not realize is that it is not just for powering on or powering off. Yes, even you can do that as well. If you want to do a graceful shutdown of a VM from command line when your ESXi host is showing as not responding, right? One of the key interesting point that I'll just, due to the constraint in time, I'll just tell about the vmsvc get.guest. That's an interesting option that you can use. Like say, for example, if I click on the web client or the vSphere client, you click the summary tab, you will get some information with regards to the VM, whether the VMware tools is running and all that. You'll be able to get all those information even from command line as well. Maybe if for some odd reason, if my host is not responding and I want to troubleshoot from command line, then this particular option will come really in handy. Like that, there are multiple options. We'll just discuss about one real-time scenario, which is vmsvc get all VMs. Remember what Abhilash talked about in hostd? If you want to validate if your hostd is working fine or not, then this is the command that you will run, vmsvc/get all VMs. If you get the output for this command, it's a simple option to isolate if your hostd is working or not. Obviously, the other option is you can launch a vSphere client or a client direct to the host as well and check. But going forward from vSphere client, we are not sure if that option is going to be available. So this is what we will be left out with for troubleshooting hostd. The second option is you can even get the task list as well. What are the tasks that are currently running against that particular virtual machine? For some odd reason, the virtual machine is hung. Are there any? And the snapshot consolidation that's happening, it's not showing in the web client or the vSphere client. Then how do I find that? Just run the task list, vmsvc/task list. That will tell you what is the task that it is stuck with. Is it trying to install VMware tools? Is it trying to create a snapshot, consolidate a snapshot? Whatever the option it is, you'll be able to find that out. So that's vim-cmd for you. The next command that we will look at is vmkfs tools. Most of you would have used this command only to consolidate snapshot, right? If your snapshot chain is broken, you want to consolidate snapshot, you run vmkfs tools-i. Now, we are going to show you three options which is not documented or which is not used in regular day-to-day troubleshooting. The key options are, first is -e, vmkfs tools-e. This command will help you to check the snapshot chain integrity. It will help you to verify the PID, CID. It doesn't matter how many layers of snapshots you have, it will help you to verify the integrity of the snapshot chain. Second is T10. This particular command will help you to check the integrity of a VMDK file. For some odd reason, if I feel that the VMDK is corrupted, remember, these are two different things, your VMDK and your guest operating system. If your VMDK file is corrupted, this particular command will help you to check the integrity of all the inodes. But if there is an operating system level corruption, this will not help you to check that. Okay? The third option is -x. So if you find some problem with that, and you want to check or repair the VMDK file, this particular command can help you to do that as well. Now, to see that command in action, So I run the same command, vmkfs tools -e, and I just point it to the last snapshot disk. If there are 3 levels of snapshot, then I will run the command, say if the VM name is test -0003.vmdk. It will check you all the integrity, all the 3 levels of snapshot, and if there is any errors, it will tell you. You can see here that there is a mismatch in the PID and CID, and the snapshot chain is broken. This other option that you can do is the X. It will help you to check the integrity of your VMDK file, and it will help you to repair if possible as well. Not that it's recoverable all the time, because if your storage went down due to some power outage, so chances of recovering it might be difficult as well. But before even reaching out to your backup vendor or some vendor like OnTrack to retrieve your data, you can always run this command. It will help you to save a lot of money. So that's vmkfs tools.
All right. So how many of you have actually heard of memstats command? Awesome. I see some hands there. Nice. So memstats also can be used for troubleshooting, right? Now, I don't want to have a fist fight with ESXstop usage, okay? So ESXstop can also be used. Let's say if I'm doing a real-time troubleshooting and I want to check the amount of latency or drops or whatever it is over a period of time. So I will collect a batch mode and then look into that. Now, memstats will give you point-in-time information of what is happening at that point in time, right? It's going to grab the information from your VM kernel and give it to you right away. Now, we're going to talk about memstats, and then -r is for the reporting, and then we will talk about vmstats itself. So let's assume that my VM is ballooning and it is swapping and things like that. So how do I even investigate that using memstats? So the first thing, again, we will have to look up for the cartel ID information. So the cartel ID would be PS grep, or you can use process list as we spoke earlier, right? So once we have the cartel ID information, you're going to execute the command memstats -r and then vmstats. You're going to look up for, you can actually filter and look up for what you want, right? So here I'm actually looking up for the name, which gives me the VM and the cartel ID name that I want. And then it gives, I'm looking up for ballooning, swap, and then swap, and the mem size and the active as well. So if you look at the output, it actually shows if my VM has ballooned, if there is a swap target or swapped messages, and what is the active running memory on my VM also. So this shows the ballooned or ballooning information of the VM. Now if we want to look up for the swap information as well, we can use memstats -r and then swap statistics. And then I can also record the information of what I need. So let's say in this case I'm using swap and then swap in and then swap out. And then I'm looking up, is it even swapping is a question, right? So I'm again looking up on the cartel ID information which we see VM 1190446. Is it swapping? It says no. If it is swapping, you will find a yes, a Y there, and then you will see the swap in and the swap out numbers if the VM is actually swapping right there. Now, how many of you have actually used PKD cap? Most of you? So today we're going to expose a neat command within PKD cap where we can actually have more detailed understanding of what is happening through that packet when it's moving on from the host or coming back from the host as well, right? So pkd cap -uw -trace is a command that we should be using to investigate my VM kernel port or the uplink on the host as well. Now, if I'm troubleshooting on the uplink, you might want to, before even I go there, right, you can capture this output of this file and then redirect it to a file as well. So even that can be done. So once you have the file, if you're doing it on the physical uplink, I would suggest the ideal approach should be to look up for the filters. So do a source and the destination filters to understand where the packet drops are. Now, if you look at more detailed information about the trace itself, you actually see the packet traversing path. I would it is actually looking, I mean, if you see the packet, it's actually moving from TCP/IP transmit, it's going to the port input, and the I/O chain and the DV filter and everything, and then at last I see the uplink send, which means that the uplink has sent it, and then it is completing the I/O chain node. Now, simple piece of information means if I have a drop in my packet, I should see it within, if I see that within this layer, that means I have a drop within the VM kernel layer itself, within the networking stack. So this is a more advanced kind of a capture where I can look at where is the packet going and then where are the drops looking around as well. So the next highlighted, in the same screenshot shows the MAC address information of the captured, port. So if you're doing it against the VM kernel port, it's actually giving you the MAC address of the port itself. So in short, I would suggest you use this for troubleshooting like virtual machine packet drops, uplink disconnects and things like that. And if you really want to investigate that the host is actually having a drop within itself, or is it outside your network, right? So you can use this to troubleshoot that piece.
So the last command that we're going to look at is ESXtop. I'm sure the question would be is that if I want to look at my ESX or the virtual machine performance related issues, I can look at it from the performance chart in vCenter or in ESXi. Why do I need ESXtop itself, right? So one of the key things that is required is, say for example, if your CPU has, there's a resource contention, you want to find out the ready percentage in your ESXi. If my ready percentage is high, that means that the virtual machine is waiting for the VM kernel to allocate resources to that. These kind of niche informations can be found only from ESXtop, and these are not available in your in your performance chart. So what are the options that are available under ESXtop is you can find information with regards to CPU, memory, disk, storage, vSAN, which was recently added, which is the option X, your network, and your power management as well. One of the other key important thing which most of the customers miss out is to look at the performance stats. The reason is because based on the C level, based on the C stats which you have set, your virtual machine performance could vary drastically. So that's another thing that you will want to keep in mind when you're troubleshooting performance-related issues. So the key thing we are going to look at is the network and the disk usage. Like we said, in network, we could look at the packet drops, or if it's a disk, we can look at the disk average latency. That will tell us where exactly the problem is. That's ESXtop. So to quickly summarize all the 7 commands, we started with ESXi, which can help you to troubleshoot all your ESXi core issues, vim-cmd for managing virtual machine related issues, vshish for a unique command that will help you to get all the information directly from VM kernel. Whenever you're using vshish, please use only with the get option. Then VMKFS tools for your VMFS and virtual machine VM disks related, memstats, PKT cap, and ESXtop.
All right, so this is the last piece of it. So we're going to talk about the configuration files. So why did we even pick up the 7 configuration files? You have, as Raghav rightly mentioned in the initial slide itself, we have 58 different files out there, which are all important. Now, before even I go to this slide, I want to make one point which is very important in the piece of troubleshooting, and then when you're taking host under maintenance, when you're bringing the host down and things like that, we mostly ignore to take a configuration backup of the ESXi host itself. How many of you actually do it? You do? Awesome. So the ESXi configuration file backup means if my host, let's say you're taking the host down for the maintenance, you have a configuration file backup. It saves all these 58 different config files along with all the XML, your SSL certificates and everything. And then once you're undergoing a maintenance window, let's say the host crashed and you had to rebuild, there's no other option. So are we going to redo the networking, the storage, all the certificates and everything from the scratch? Rather, I can restore this config back again to the host where I can be as normal as I was where I started, right? So we're going to talk about 7 files today. ESX.conf, this holds the storage, the network, the hardware details, and everything. So we spoke about the perennially reserved flag in the first slide, right? So this file actually holds the key of your entire ESXi host. Now, inventory.xml actually reads or has the update of what are the different virtual machines in your ESXi box. If this file is corrupt or gone bad, you will see the VMs going inaccessible. You will not see the VMs getting registered themselves as well. So the next file is authorization.xml. This is the file that initiates or authorizes the connection between the ESXi host and the VC. If this file has gone bad, the connection never establishes. So we have vpxa.cfg, which is the configuration file important to connect to the VPXD on your vCenter. Why is this important? If you miss or this file has gone corrupt, this holds the IP address and other details of your VC itself, which will go bad, right? So you will not be able to successfully connect also. Now the next file would be iSCSI.conf, which holds the iSCSI information. So you'll have your database, iSCSI DB, and other files inside it as well. Now the conf file will hold the IQN details and other important details of your initiator of the host. And if this file goes bad, you're again going to rebuild the host with restarting all your iSCSI configurations. Your FDM actually holds your host file list, your cluster config, your VMs, metadata, and things like that. Now, if this goes bad, again, you are into trouble on the HA configuration side of it. And the last one is your license.cfg. Now, this file holds the license configuration of the host. And if this goes bad, you have trouble in your licensing on the host side. As I said, we have 58 different files. I'm just bringing up the 7 important ones, but that doesn't mean that the others are not important. So it's really important when you are undergoing a maintenance, you have a safe backup. And the way how do you back up? I mean, can anyone call out how do we even back up the host configuration? Yes. Yes. That's one way. That's the older way. You have autobackup.sh, as she said. Now, we have vim-cmd, which we spoke about. We have host svc, and then you have an option called firmware. So you can do a firmware backup, and then you can also do a firmware restore from the same command. So it is vim-cmd/host svc, and then you have a firmware option. So folks, that brings us to the end of this session. I hope it was effective. And we will walk down. If you have any questions, you can reach out to us. And thank you all for staying back for this Thursday.
Thank you, everyone.
Thanks once again.
Thank you so much for your time.